Is Kubernetes getting boring?
In this last decade, we've seen an amazing adoption of the Kubernetes platform. Close to 80% of organizations are running Kubernetes in either dev or production.
Few years ago, you would wake up to see a new Kubernetes distribution. Does it really matter to enterprises?
One of the great design philosophies Kubernetes did, unlike OpenStack, is building very rich API specifications and standards. You cannot expect it to underlying change major aspects. Everything that I mentioned, Johnny, is something actually that we work very closely with Intel on called a secure edge native architecture.
Do you start securing the stack all the way from the processor?
Everything. If the chain in the beginning is broken, there's no way to verify that the actual tail end of your application is also secure.
Ladies and gentlemen, welcome Saad Malik. Ladies and gentlemen, welcome back to yet another episode of The Encounter, where we talk to the leaders from the cloud native industry. So today I have a very special guest, Saad Malik, who is the co-founder and CTO at Spectro Cloud. Saad, it's great to have you.
Pleasure being here. Thank you for inviting me.
Awesome. So Saad, I want to get started with this obvious question. You have been in the industry and you have been in the cloud native space for a long time. So my first question is Kubernetes getting boring? Have enterprises started to adopt it, and did that turn Kubernetes becoming a boring technology?
Yeah, that's a great question. It's something obviously true to our heart. So Kubernetes is coming up to its 10th birthday. In fact, fun fact, the first check-in into Kubernetes codebase was June 6, 2014. So just a few more days and we'll get there. Now, in this last decade, we've seen an amazing adoption of the Kubernetes platform. It's obviously become the de facto container orchestrator, and now close to 80% of organizations are running Kubernetes in either dev or production. And obviously that number is going to be increasing. When you look at Kubernetes today, it still has a very healthy release lifecycle. We're seeing close to around 3 releases per year. Now, these releases are, of course, bringing capabilities like having better pod health checks, being able to do volume group snapshots and other capabilities. But Johnny, these changes aren't fundamentally changing the underlying technology of how Kubernetes works, how the orchestrations and pods and service sequences, all those are stable. And you kind of need it to be stable for adoption in an enterprise organization. If you have because now Kubernetes is this critical business infrastructure that all mission critical applications are running on, you cannot expect it to underlying change major aspect. So it has become boring in that sense. Now, I think where the fun is all the innovation happening on top of that Kubernetes ecosystem. And as you know, Johnny, there are over 1,800 plus different integrations in the CNCF landscape. And these integrations cover everything from storage to networking, logging and monitoring. And every day we see innovation when it comes to serverless technologies, WebAssembly technologies, running large language models in Kubernetes. So I think that's where the fun is being had, is the layers on top. But the core infrastructure, I think, is stable and mature.
Absolutely. I think we need that stability and sometimes being boring because there is no breaking change. The API has become very consistent. That's very important for the ecosystem to mature, evolve, and ultimately for the enterprise adoption. So that actually brings me to the next question. There was a time when a lot of companies were competing and racing to offer a new distribution. Almost everyone in the cloud native space had some kind of a flavor of Kubernetes. And today you can compare that to an LLM kind of cadence. And every week you wake up to see a new LLM. And a few years ago, you would wake up to see a new Kubernetes distribution. So my question is, does it really matter to enterprises? And when an enterprise is choosing Kubernetes as a platform, what is the criteria? What is the kind of the metric that they use to handpick one distribution versus the other?
Yeah, I think One of the great design philosophies that Kubernetes did, unlike OpenStack, is building very rich API specifications and standards. Right? These would be the integration points that deal with networking, like the CNI layer, storage CSIs, runtimes, CRI. And in addition to just the integration points, even how Kubernetes itself operates and runs, they built a very, very comprehensive conformance tool that does 1,000+ different tests across everything from how pod is being launched to node lifecycle management to how services work. Now, what we find is that every single distribution that enterprises and organizations use around the world, whether it's your managed Kubernetes providers like EKS, GKE, or AKS, or using something on-prem, they're all 100% conformant to the actual Kubernetes specifications. So that means that for enterprises, you get true portability. Doesn't matter today if you're running a Kubernetes application on a single managed Kubernetes provider like EKS, and tomorrow moving it to VMware Tanzu, as an example, because the applications are built towards this standard. So in general, it doesn't really matter where the app runs. Now, of course, there may be certain reasons why for an organization you may want to have one distribution over another. For example, if you are in the cloud, most likely you would leverage the managed Kubernetes providers because the cloud service provider is the one implementing the control plane. You're not managing the lifecycle of that. Everything from the recycling, upgrade lifecycle is all managed by the cloud itself. If you're running it in an edge environment or small, maybe footprint environment where you don't have a lot of capacity and capabilities, you may want to run a smaller distribution like K3s from Rancher or Canonical's Spectro Kubernetes. If you have some security requirements, I want to have FIPS 140 compliant Kubernetes distributions that are completely encrypted and secure. You may use something like Spectro Cloud's own Vertex distribution that is FIPS compliant. So there are, of course, differences from that perspective, but in general, we're seeing that enterprises don't really care too much other than, if they have some specific use case. The challenges are, how do I actually manage at scale all these different distributions? And most enterprises don't just have one, they have multiple of these. So,
Absolutely. So coming to another interesting aspect, Kubernetes is positioned as the meta control plane, and it can essentially orchestrate anything that can be scheduled. So that led us to virtualization, getting subsumed into the realm of Kubernetes. So how do you see that, particularly from Spectro Cloud's point of view? Are you seeing Kubernetes managing VMs? Are customers embracing both containers and VMs and use Kubernetes to orchestrate both of them?
yeah. I mean, we call it now legacy workloads, even though 85% of workloads today that run are virtualization. Container still is 15% or less. And obviously that over time, that number will grow. Today, we see a paradigm where there are multiple teams that manage the infrastructure for virtualizations, the VM technologies themselves, and a separate team that is now running the container orchestrator in Kubernetes. What we're seeing is that because some CIOs and CTOs are realizing that more and more of their actual workloads will essentially become containers or serverless that run in Kubernetes, why have two separate platforms that are managing VMs and actual containers? With the rise of technologies like KubeVirt, you really now can run virtualized VMs inside of a Kubernetes cluster that is running bare metal. And so we're seeing that Kubernetes has become also, with this amazing API support, a single platform now where you can run both containers and VM technologies. I mean, especially, Johnny, with this whole Broadcom and VMware aspect coming on too, many organizations are looking to de-risk their VMware investments and looking for alternatives. And if they're already moving into Kubernetes, they're definitely looking into technologies like KubeVirt.
Absolutely, absolutely. So that brings me to the next segment, which is edge. So what is the state of Kubernetes at the edge?
I think Edge has become the next phase of multi-cloud, right? It's enabling real business outcomes and models that were never possible before. And we're seeing this year-over-year adoption across so many different type of vendors and verticals, from healthcare to manufacturing to telcos. And all of these organizations are leveraging edge computing either for data pre-processing, either for AI inferencing, or IoT and robotics. But Edge, of course, does bring its own complexities. It's not running in a data center where you have all this technical talent. You're running it in a McDonald's store or a Starbucks or somewhere else. How do you get the store manager to be able to heal your operating system or your Kubernetes? That does not happen. You cannot expect them to do that. Also, many of these edge environments run in very ruggedized, where these are zero connectivity or limited connectivity that is bouncing up and down. And most edge deployments don't just have one or 10 deployments. There's hundreds to thousands of deployments. So how do you then provide, of course, the manageability of all these edge locations, at scale? And these are, of course, true and dear to the heart of Spectro Cloud and how we also help manage it. But we are seeing massive adoption of edge computing across all industries.
Right, right. So, when it comes to edge, security becomes paramount. Of course, security is of paramount importance everywhere, but it is much more sensitive at the edge because it runs in a very uncontrolled, very accessible locations. So, from Spectro Cloud's point of view and as a technologist, what do you think are the best practices and how can you secure the edge, particularly that's something which is running Kubernetes?
Yeah, absolutely. And security, to your point, comes in two different flavors. There is the actual physical security, where sometimes these edge computing projects run on towers or unmanned locations where you don't have any person there at all. So how do you want to protect against if somebody comes and steal your device and being able to read information from that? But then there's also the security when it comes to the application stack. How do you ensure that there is no third party, malicious user that is now forcing specific applications of code onto all your edge devices? So I think for security, when it comes to edge, it covers the entire gamut from being able to verify your actual device, from trusted onboarding of your device into your platform. How do you provision the end-to-end stack of applications and integrations? And then potentially provide runtime security where even in the memory itself is encrypted using something like confidential computing. Everything that I mentioned, Johnny, is something actually that we work very closely with Intel on, called a secure edge native architecture. And essentially, it's a reference architecture where we cover the end-to-end operations on how to deal with security. Everything from physical down to the onboarding and provisioning to the runtime security. And something maybe, Johnny, in the show notes, we can even link to if somebody's interested on
Sure.
how they can read the reference architecture for that.
Perfect, perfect. So, just curious, because you said Intel, do you go down to the lowest level of the stack, like the processor, the TPM? Do you start securing the stack all the way from the processor?
Everything. So from us, from our perspective itself, security is broken if it doesn't start from the very time the initial boot happens. Everything from the firmware has to be verified that it's secure and is trusted, to the EF5 bootloader that is loading, to the operating system that is initially loading. All the binders have to be completely loaded. If the chain in the beginning is broken, there's no way to verify that the actual tail end of your application is also secure. So we leverage all the technologies like SGX and TPM to verify that the operations are completely secure.
Perfect, perfect. And the most trending topic and the buzzword, and I almost asked this to all my guests. So, what do you think of Gen AI for the cloud native ecosystem?
Wow, that's a good question. I think ChatGPT completely revolutionized how I think many of us work. Right? I mean, this is just not outside of cloud native specifically. Everything from writing emails to grammar checks, even me using Google to ask like, "Hey, what muscle is this?" I don't use Google anymore. I just directly go to ChatGPT and ask, because the reason is because it has context and I'm able to ask follow-up questions. I think when it comes to technology and specifically cloud native technologies, we're seeing all of these different capabilities being embedded into the technologies themselves. We're working with customers now that are leveraging large language models inside of hospitals that, as a patient and doctor are communicating, the LLM model is not only transcribing, but is giving recommendations in real time for prompts that the doctor should be asking the patient itself. We're seeing use cases where inside of remote edge locations like an oil rig, where when an operator comes to repair a faulty device, right, how are you able to then provide visibility and generate a script that says, these are the parts you have to replace, and this is how you do it, to the point where it's multimodal, where a video is generated showing them exactly how to fix it. so they don't have to read a 300-page manual on how to fix these parts. So this is just some of the interesting use cases, and the different technologies in the cloud native, of course, are offering the ability to run these kind of workloads.
Perfect. So where do you see the intersection of Gen AI and cloud native?
I think to be honest, it's going to be more about being able to run all of these LLM technologies and GenAIs inside of different ecosystems. Whether those ecosystems are going to be in edge environments or in data center environments. I think the other aspect is right now the large language models are very generic. How do you provide these technologies that are able to directly run them on, be able to provide very specific use cases on your organization's needs? Being able to run embeddings, right? Being able to run vectorized databases that provide insights for how you are essentially running your LLMs.
We are almost at the end of this discussion, and I want to wrap this up by asking you what's the roadmap for Spectro Cloud? And if you can briefly mention the portfolio of your products and what to expect in the next couple of quarters, that would be great.
Sure, absolutely. So our platform is composed of three different verticals that we provide. First one is on Kubernetes as a service. This is where we help enterprises to run Kubernetes at scale, whether you're running it in public clouds, private clouds, data centers, or edge environments. Generally, platform engineering teams that are providing Kubernetes to their end users, which are developer teams, right? How do they provide aspects like all the various integrations? How do they provide security and RBAC management? These are all part of the enterprise capabilities that we provide in Palette. The second offering is around our edge environment. I mentioned some of the challenges that edge really comes into, right? How do we make it easy for organizations that are running edge computing at scale to be able to operate and manage hundreds, thousands, tens of thousands of locations with ease? And the third area is what we call PDE, Palette Dev Engine.